Previous research has led scientists and politicians to believe that regrowing forests on northern lands that were cleared in order to grow crops would not decrease global warming. But these studies did not consider the importance of the choices made by farmers in the past. Carnegie researchers Julia Pongratz and Caldeira have concluded research indicating that decisions made by farmers in the past to plant on productive land that had little snowfall increased the potential that reforestation may be able to counteract global warming. The Earth has been getting warmer over at least the past several decades, primarily as a result of the emissions of carbon dioxide from the burning of coal, oil, and gas, as well as the clearing of forests. One strategy for slowing or reversing the increase in atmospheric concentrations of carbon dioxide is to regrow forests on abandoned agricultural land. But the proposal has been difficult to evaluate because forests can either cool or warm the climate. The cooling effects come from carbon dioxide uptake. When forests grow, they absorb the greenhouse gas carbon dioxide from the atmosphere and store the carbon in plant biomass and litter as found in branches, trunks, roots, and soils. This carbon dioxide absorption has a cooling influence on our planet's temperature. The warming effect comes from the absorption of solar radiation. Forests are often darker than agricultural lands because they absorb more solar radiation. More importantly, forests in the spring often have snow-free and highly absorbing trees at a time when fields and pastures are still snow-covered and reflective. As a result, forests generally absorb more sunlight than fields or pasture, and this increased absorption of sunlight has a warming influence, with this effect felt most strongly in the snowy areas of the world. Previous studies of the potential for reforestation to reduce temperature used unrealistic and highly idealized scenarios. The study by Dr. Pongratz and colleagues for the first time considered historical patterns of land use conversion.
And we find that farmers in the past chose land to be cleared for agriculture in a very specific way, which indeed makes the carbon dioxide effects stronger, but the reflectivity effects weaker. And this overall leads to a bias that makes reforestation on area that has been cleared in the past more effective than had been thought from previous studies that always looked at hypothetical large-scale reforestation around the entire globe.
The implications of this for the cooling potential of reforestation had been ignored. Regrowing forests on these productive lands can take up a lot of the greenhouse gas carbon dioxide and therefore have a strong cooling influence. Because these lands are not very snowy, regrowing forests would not absorb very much additional sunlight. The net effect of the historical preference for productive, snow-free land was to increase the climate cooling potential for reforestation on this land. Taking historical factors into account shows that reforestation has more climate cooling potential than previously recognized. The potential cooling effect of reforestation is enhanced because farmers in the past chose to use productive lands that are largely snow-free. Researchers cannot yet say whether any particular proposed reforestation project would have an overall cooling or warming influence. Nevertheless, broad trends are becoming apparent. The Carnegie Institution has had over 100 years of extraordinary discoveries. To continue this tradition, Carnegie scientists need your support. For more information about this and other cool science, visit our website at carnegiescience.edu. This is John Strom.